Okay, so now we're going to look at some application problems with exponential functions. And there's actually some courses you could take that focus a lot on this kind of stuff. And so we're going to kind of just touch the surface on this, but we're going to look at compound interest. And so compound interest is interest computed on your original investment as well as your new accumulated wealth. So for example, if you were, let's keep this kind of simple. If you were to invest, let's say $100 in year zero, okay, that's your principal, that's what you're investing. Let's say that you're getting a 10% return. So you'd get your $100 and you'd multiply it by 1 plus, on percents, we're going to have to move it 2 decimal places, so that'd be 0.1. So you would get your $100 back plus you'd get $10 back, right? So that was the interest you earned. You earned 10%. So the next year, what's going to happen is you're going to get 10% again, but you're going to get 10% of the already accumulated wealth. So that's compound interest right there. So you're earning money on the money that has already been earned. Okay. And so this is kind of an example of it. So every time you're going to compound it, you multiply it by 1 plus the rate of return. And so, for example, let's say that you have $100 and you're getting a 10% return every year for 5 years. Instead of having to write it out as 1 plus 0.15 times, you can just raise it to the power of 5. And so let's see, I'll go ahead and, if you don't have, you can use whatever calculator you want, but you should be able to download something similar to this for free. If you go look in the syllabus, I have some links for that. So you can download it for like a 90-day trial, which will be more than enough for what we're doing here. So let's see, I'm just going to put it in as 1.1, because if I add 0.1 to 1, it'd be 1.1. And I'm going to raise it to the power of 5. So that $100 would be worth $161 and about 5 cents right there. So that's just a very basic example right there. So you have your principal, which you invest, your rate of return, and then the T is going to be how many years is that investment going to be in there. Now, this is compound interest for annual compounds. We're going to look at other interest that's compounded more frequently in a moment on the next page, but we kind of just want to start with some simple examples. So using this formula right here, we have a formula for growth, which is the one we just used. So you invest your money and it's going to grow, right? So you have your A is going to be the final amount, P is your initial amount, R is the rate, and T is time. Now, if you were to subtract the rate, that would be a formula for decay. And we'll look at an example of that in a moment. So let's go ahead and look at our first example right here. So it says the starting salary for a new employee at the Thrifty Federal Credit Union is $35,000. So that's what your starting salary is. The salary increases by 3% each year. What will be the employee's salary after 10 years? So we want to figure out how much they're going to be earning after 10 years. So what we're going to do here, so let's see, our initial amount, when you get hired, you're going to be making $35,000, okay? You're going to get an increase of 3% each year, so you got to move that 2 decimal places and put it as 0.03. So whenever our R value will always be a decimal like that, okay? So be careful. And then let's see, what else? Oh, okay, we want to know the salary after 10 years. So time is 10 years. So we want to know how much we're going to be making after a 10-year period. And then we'll round to the nearest penny. So we'll go ahead and fill out what we know. So A equals, and so obviously we're doing the growth formula on this first one. Let's see, 35,000 and 1 plus 0.03 raised to the power of 10. And you don't have to have this graphing calculator, but it makes it a little bit easy to put in. But I mean, even your phone calculator would probably be fine. So let's see, 35,000, and then 1 plus 0.03, which would be 1.03. So I just go ahead and add that together, okay? And then I have to raise it to a power of 10. And so after 10 years, your salary would be about $47,037.07. So let's see. Oops. Let's see. My pen will work. Let's see. 40. Okay, so something's going wrong with my software, but the answer is $47,037.07. So I'm going to have to use my Word document for as I move forward. Okay, so looking at this right here, it says the car is originally priced at $35,000. It loses 15%. So now we're doing the decay one. It loses 15% of its value each year. What is the value of the car in 3 years? So once again, the original value of the car is $35,000. Let's see, our rate is going to be 0.15. So you got to move it, always move it 2 decimal places. We want to know what the value of the car is in 3 years. So the only difference here is now we're going to subtract the rate from 1. So A equals 35,000, 1, and then we're losing 15%. And we're going to lose 15% for 3 years. And so we're going to figure out what the value of the car is 3 years from now. So once again, I'll put this in my calculator. All right, so 35,000. And then we're going to multiply that by 1 minus 0.15, which if you want to, you can put in as 0.85, or if you want to put in 1 minus 0.15, that's fine too. And then we're going to raise it to the power of 3. So that car you buy for $35,000, 3 years later, it's only worth $21,494, and we'll round that up to 38 cents right there. So let me go ahead and just going to take a picture of that. So there we are. So the car would be worth $21,494, and then we have to round that up to 38 cents if we're rounding to the nearest penny. Okay, so this is pretty simple compound interest when you're looking at it on an annual basis, okay? But what if, typically when you make an investment, you want them to compound it as often as possible so that you can make money off of the money that's already been earned. So remember, that's what compound interest is that you're making money off of the original investment as well as the new accumulated wealth that you have earned from your investment. So this formula is going to be a little bit more to it. And so what's going on right here, so the formula on the previous page is designed for annual compounding, but the more often you compound, the faster your investment will grow because you're going to earn money off of the money. The following formula allows for additional compounding within a year's time. We'll focus on the growth model. So we're only going to be looking at growth here. Okay. So right here, the formula looks very similar. The only difference is you have this n variable. That's the only difference from the previous formulas, that you're dividing your rate by n and you're multiplying time by n. Well, n is the number of times you're going to compound within a year. So your rate of return, you got to divide it by how many times you're going to compound it within that year, because if you're getting a 10% return every time you compound it, the bank's not going to give you 10% every month. That would be crazy. You would, they wouldn't be able to keep up with that. So you have to divide it by the number of times you're going to compound that within a year. Now that will make the return smaller. Okay, and so then also the time is going to get multiplied by that number of times you're going to compound right there, okay? I wouldn't worry too much about this. If, like I said, if you take a financial course later on, you'll investigate this formula a little bit deeper, okay? R is still your rate, T is still the time in years, okay? Well, we have one other formula to look at, and that's what if you want your investment to be compounded trillions of times per second? So every time you make even just a fraction of a penny, you want it to roll into your investment side. You want to earn money off of that new money every second that you earn another penny, right? So remember that special number E, Euler's number that we looked at in previous videos? We have a formula for continuous compound interest that uses the E. And so A, your accumulated value, is going to be equal to your principal times E raised to the power of R times T, where R is the rate and T is the time again, okay? So a lot of times people refer to this as PERT, P-E-R-T, to help you kind of memorize this formula right here, okay? So what we're going to do now is we're going to look at this example that's going to have us investing money, and we're going to look at investing in different ways. Okay, so right here it says find the accumulated value of an investment of $10,000 for 5 years at an interest rate of 5.5%. If the money is compounded semi-annually, compounded quarterly, monthly, or compounded continuously. Okay, so what I'm going to do here is I'm going to go ahead and write out my knowns. So I know that I have 10,000 that we're going to invest, okay? I know that it's going to be for 5 years, and I know that my rate of return is 5.5%. So I have to write that as 0.055. So you always move the decimal spot to the left 2 spots. Okay, so those values are not going to change, but now we have parts A, B, C, and D. Now that is going to be different. That's going to affect my N value, the number of times I'm going to compound it. So looking at part A right here, if I'm compounding semi-annually, that means twice a year. So my N value is going to be equal to 2. Okay, so now let's go ahead and write out my formula. So it's going to be A equals, I'm investing $10,000, and then it's going to be 1 plus my rate of return, which is 0.055, all divided by my N value, which is going to be 2, and then raise to the power of N times T, which is going to be 2 times 5. So if you look back up at my formula right there, I'm just plugging all that stuff in right here. Okay, so you just need to be careful with how you're going to put it in your calculator. This one's probably the most user-friendly, but it's not the only one that will work. Even your phone would be fine. If you're going to put it in your phone, you'd probably want to figure out what's this inside the parentheses first, then raise it to the power, and then multiply it by 10,000. But with this calculator, and like I said, if you go onto the syllabus, you should be able to find a link where you could download one pretty identical to this for free for a trial. So let's see, 10,000. Let's see, parentheses 1 plus 0.055. Close it, or oops, divided by 2. Then I'll close it. And then I'm going to raise it to the power of, I'm just going to go ahead and put 10. If I write 2 times 5, the calculator will actually not read it correctly. It'll read it as though I'm multiplying by 5 after the fact. So go ahead and figure out what that is and just type it in once so that you don't have to deal with any of those syntax issues. Okay, so let's see. My investment would be worth $13,116.51. So let's see. 51 cents. Okay, there we go. There's the first one. All right, so let's look at part B. Part B, the only difference here is I'm going to compound quarterly. So my investment, I'm going to earn money off of my money earlier because I'm going to do it 4 times a year. Okay, this other one was only 2 times. So it's not going to be a big difference. It might only be $1 or $2, to be honest. this is a short time that we're investing. The rate's a decent rate actually, but it's not going to make that big of a difference. But so let's see, A equals 10,000. Let's see, 1 plus 0.055, and we'll divide that by 4 this time, and then it'll be 4 times 5 is going to be my exponent. So what I can do here, I think, if I press second enter, it will retype my whole thing, and I can arrow back and kind of change the numbers as needed. So let's see, that should be a 4, and then my exponent would be 4 times 5, which should be 20. So that's another nice feature with this, is if you press second enter, it'll just pop back up what you already have, and you can adjust it as needed if there's just a couple things that are different. Press enter, and actually that made a decent difference, actually, more than I was thinking. So yeah, you're gonna earn a couple extra bucks there. So let's see, 13,140, and that's gonna round us to 67 cents right there. So you have to be careful on your rounding. So let's see, 13,140 and 67 cents. Okay, pull that back up. So you have to be careful. So because after my 6 there's a 5 or higher, you have to round up. So that rounded that up to 67 cents right there. So yeah, I ended up making decent amount more right there. Not bad. Okay, let's look at part C, and then part D is actually the easiest one. Continuously compounded is pretty simple. So let's see, on part C, let's see, we're going to compound monthly. So that number now is going to be a 12. So let's see, A equals 10,000 times 1 plus 0.055 divided by 12 raised to the power of 12 times 5. And once again, it'll make a difference. It won't be a huge difference, but it'll make some difference. All right, so pull up my calculator. Let's see, that's kind of in the way. Let's see, move that. There we go, that's better. Okay, so second enter, and I'll go back up here. I'll change that 4 to a 12. So 12 is a double-digit number, so it's going to start typing on my old stuff, which is fine. So I'll close that parentheses. Then I'll say to the power of 12 times 5 is 60. So I'm going to put 60 up there. Okay. So I went ahead and did that. We'll go ahead and press enter. So 13,157, and let's see, that will round to 4 cents. So 13,157 and 4 cents. Let's see, that looks good to me. So once again, I had to round that 3 up to a 4 because of the 7 right there. Okay, on our last example here, part D, we're going to look at continuously compounded. So we're actually looking at a different formula. We're looking at the PERT formula. So there is no end value. We're actually just using a different formula here. So let's see, we're going to have 10,000 times E raised to my rate, which is 0.055. And then I have to multiply that by time, which will be 5 years. Okay, so this is continuously compounded. So basically, anytime I'm earning money, it's going to go into my investment part of my account. So I can make money off of it right away. All right, so once again, depending on what calculator you're using, it might look a little different, but this one's pretty user-friendly. So I have 10,000. Now I have a couple different ways of getting the E. If you look right here, the division sign, if I press second division, the E will come up. Or, oops, Didn't mean to clear the whole thing out. Or if I press second ln, what I like about that one is it gives me e to the power of. So I already have the power of, and it gives me a parentheses. Now that parentheses is important because if you don't put the 0.055 times 5 in parentheses, once again the calculator, it's going to read it incorrectly. So 0.055, and then I'm going to multiply it by 5, close that parentheses, and I should be good to go. So let's see, 13,165 and 31 cents. So 13,165 and 13 or 31 cents. Sorry, my dyslexia is kicking in. All right, so let's see, 31 cents. There we go. So that would be what we'd get in return. So just real quick, so see, if I would have put 10,000 e raised to 0.055 and then I multiply it by 5, it's going to read it incorrectly. It's going to multiply by 5 after the exponent, so it's going in orders of operation. And so see, look at that number that comes back. So that's incorrect. So you want to be careful the way you put it in your calculator. You could always figure out what that number is first and then raise it to that value if you want to. But anyways, play around with it. Be careful. If you have any questions or concerns, feel free to email me.